Let's consider this. If I had y equals x squared minus x, minus 2, what is that? If I have y equals a quadratic, what does that actually mean or do, or what's going on here? It's not exponential. What does the graph look like? What shape is the graph? It's a parabola. So it looks like this. Okay. What if I change this equation? I throw out the y, and I insert a 0. How does that change the graph? It throws out every single point except y equals 0. So if I say y equals 0, I want to know where does that hit the x-axis. And we've done this over and over. So we can factor. We get x minus 2 times x plus 1. So x equals 2 and negative 1. So when it said y equals, it's the entire graph. When I change it to 0 equals, it's these 2 points. Okay, so we kind of smash the graph down to those 2 points. Today, we're going to look at 0 is greater than x squared minus x minus 2. Okay, and you have to be a little bit careful because you would assume that we would shade up, right? Well, not necessarily. It's, if it said y is greater, then you shade. If it says 0 is greater, you throw away parts of the graph except for the parts that make it true. But you always have to look at it in terms of the equation compared to 0 instead of 0 compared to the equation. So it says the equation is smaller than or equal to 0. What parts of the equation are smaller than or equal to 0? The bottom. And do I include those roots? How do I tell? Equal to. So those roots need to be shaded in. And then I take the rest of the graph and get rid of it. So there's a big difference between y is less than or equal to x squared and 0 is less than or equal to x squared. Okay? If it's y is less than or equal, so here's the x squared graph. If it's y is less than or equal, then I shade this. Okay, because it's every point less than, every y value less than the x squared. If it's 0 is less than or x, then I just look at the parts of the graph that are below or above the x-axis. Does that make sense? So it's not hard to do. So let's say we have x squared plus 3x minus 4 is greater than 0. So I factor this. X plus 4, x minus 1 is greater than 0. What are my roots? Negative 4 and positive 1. So my normal graph is going to look like this. But I need every point bigger than 0, right? So not including the roots. So that's my answer. That's the basis of what we're going to do today. The equations are a little bit more complicated than this. Okay? But it's stuff that you all know. We just have to kind of put it all together. So look at page 123. So example 8 on 123. Yeah, don't blame you. Okay, so let's pretend first that this was x minus 2 and x plus 3, like that. So the roots are, you set this equal to 0 and you set this equal to 0. Anytime you have numbers multiplied together that equal 0, for instance, a times b equals 0, then either a is 0, b is 0, or both. Okay? So we're going to split this into two multiplications, this one and this one. We do that to find the roots. So my roots are x minus 2 equals 0. So x is 2, positive 2. Okay? And then the square root of x plus 3 equals 0. Well, how do I undo a square root? Square it. So I square this and I square this. That cancels. What's the square of 0? 0. So x plus 3 equals 0. So x equals negative 3. Everybody okay so far? So x equals 2 and negative 3. Okay? So we need to set up this bar that they have right here. So I'm going to do it on a new page. So I'm going to draw a line. This is my root negative 3, and this is my root 2. Okay? There's something else we have to consider. So x minus 2 times the square root of x plus 3. Are there parts of the domain that don't exist? When does the domain not exist? When the number inside a square root is negative, or dividing by 0, or that logarithm problem we ran into, which doesn't happen very often, so we'll forget about that. So I need to make sure that x plus 3 is positive, or 0. How do I do that? Well, I'm going to set this up as bigger than or equal to 0, right? Because if x plus 3 is 0, is my square root okay? Yes. As long as my x plus 3 is 0 or positive, I'm fine. But if my x plus 3 is negative, then I get undefined because there's a negative square root. Okay? So that tells me that x has to be bigger than or equal to negative 3. Okay? So on this line that I've drawn, this doesn't even exist. I don't need to worry about those. Because negative 3, anything smaller than negative 3 will give me undefined. Well, it'll give me an I, which technically is undefined. Okay? And then I want to know, between here, is a graph positive or negative? So we need to pick a number between negative 3 and 2. What's the easiest number? 0. So let's look. 0 minus 2 is negative times, well, I don't even need to plug it in here. What do I know this is? It has to be positive. Why? If it's negative, it doesn't exist, and we already figured out where it's negative. So this is positive. Negative times positive is negative. Okay? We need to pick a number over here. What should we pick? 3. 3 minus 2 is positive times. This is always positive, no matter what. Square roots have to be positive. So a positive times a positive is a positive. Okay. Now, you might wonder, why do we keep doing these silly little charts like this? And it's because you're going to need to know how to do them later. Okay? So, now we want to plug this graph into our calculator. So type in x minus 2 times the square root of 3 plus x. And push graph. Why doesn't it touch? It doesn't touch for the same reasons that circles didn't touch. If you have a graph that gets really steep and ends, the calculator gives up. So remember when we used to graph circles and they looked like this? Because they got steep and they ended, the calculator said, forget it, I'm not going to graph anymore. So we know that that actually touches the x-axis. Okay? And the original problem was, when is this graph bigger than or equal to 0? So from 2 on, is 2 open or closed? So 2 is closed, going up. And then negative 3 is just a closed dot, right? And that's the answer. That's the graph. Okay? So what is the solution set for x's? How would we describe all possible x's? X equals negative 3 is one of the numbers. And then there's a set of numbers. How do we describe that set? From 2 to infinity, right? So every x from 2 to infinity is part of the domain. So from 2 to infinity, what symbols do I use? Parenthesis on infinity and a bracket on 2. Okay? And now that I think about it, maybe I won't make you do this part. So I want you to find the roots and then draw the graph and then write this. And I'll do another one with you. Okay? What happens if, so this was x minus 2 times x plus 3 greater than or equal to 0. How would my answer change if I got rid of the equal to? Then this 2 would be open, so that would change the bracket to a parenthesis, and the negative 3 would turn into an open circle, which is really nothing. Do you guys see that? If you have one point, and you change that one point to an open circle, you've deleted that point, and it disappears. So if you have a root that stops like this one did, so the graph actually went like that, and that root is the end of the line, and you turn the end of the line to an open circle, then it disappears. Okay? So look at your problem set on page 125. Well, we'll do a harder one in a minute. So x squared plus x minus 12. And it's greater than or equal to 0. So first we need to find the roots. X, oops. What do I know about the factors? One's positive and one's negative. Positive 4 and negative 3. So my roots are negative 4 and 3. Okay? Do I even need to graph this to figure out what it looks like? Does this parabola open up or down? It opens up, so we don't even need the graph to do it. If you don't know how to do it, go ahead and graph it. And greater than or equal to 0, are my roots going to be open or closed? So my roots are both closed. And what part of the graph am I going to draw? Above. So the original parabola would look something like this, but my graph will be those. That's pretty simple, right? No, no big mysteries? No, no. It's only those part of the graphs above the x-axis. And again, there's a difference between x squared plus x minus 12 is greater than or equal to 0, and x squared plus x minus 12 greater than or equal to y. There's a huge difference there. Okay? The top one looks at the portions of the graph above the x-axis. The bottom one looks at, so y is less than the graph. The bottom graph looks like this. And you shade everything below the graph. Okay, that's a big change. We've never done anything like the one we're doing now. So there's a difference there. There's a difference between equals 0 and equals y. Okay. A harder one would be, well, what about number 3? Number 3 is not hard, but what do you need to do? You need to move that 4 over before you do anything else. It has to equal 0. Okay? So let's do number 10. Okay. What do I need to know first? So the undefined portions. So in the bottom, x is not allowed to be 2 and negative 2. Plus or minus 2. Everybody okay with that? Now, are these going to be wholes or asymptotes? They're going to be asymptotes because they didn't cancel. Okay? I also need to know what the roots are. How do I find the roots? Well, if I want to know where a fraction equals 0, the top has to equal 0. So the roots are 1. So x equals 1. Okay? Are my roots going to be included in the solution set? No. Which part of the graph am I going to keep, the top or the bottom? Bottom, excluding the roots. So all we need to do is graph, and make sure you put these in parentheses, x minus 1 divided by x squared minus 4 . So those are the two asymptotes, and you see the root is also there. So I have an asymptote at negative 2. I have an asymptote at positive 2. I have a root at 1, but it's an open circle because it's not equal. And I'm only going to draw the bottom half of the graph. So this part, and that's it. So what is the solution set? X equals from negative infinity to negative 2, and both of those are parentheses. And then from 1 to 2, what are the symbols on those? The root is open circle, so it's open circle, and 2 is an asymptote, so it's also open, an open parenthesis. Does that make sense? You want to see another one? Well, 2 to infinity exists on the graph, but it doesn't satisfy the less than 0 requirement. So this tossed out everything above the axis. So without that, then yes, you would do 2 to infinity. But we ignore it because it's not below the x-axis. Okay. You're not going to be doing the story problems. So why don't we do number 14? Okay, so roots. What's the root of the first factor? 1/2. What's the root of the second factor? -4. Because the square root of 0 is 0, so the inside is made 0 by -4. I also know that part of the graph is not going to exist. Anything left of -4 does not exist. Okay? So I'm going to draw everything below the axis. Do the roots count? In this case, no. So to find out what the graph looks like, 2x minus 1 times the square root of x plus 4. Oh boy. I just love this new calculator. No. That is so annoying. Okay. Okay. What do we know about that graph that doesn't show? It does actually hit -4. So we know that one of the roots is -4. So the graph really looks like this. Oops. Except it touches at 1/2. Okay? So how much of that graph am I going to keep? From the root -4 to the root 1/2 and everything in between. So the answer, my solution set is what? -4 to 1/2. What symbols do I use? Like that. So that is my answer. Okay, can we handle that? Don't do the story problems. Now, we're not going to do them at all, so when you finish this, you can hand it in. But it should be pretty easy. I don't think this is tough. I hope it's not tough. All right, good luck.